inside someone's mind? This seemingly purely philosophical question has haunted thinkers and scientists for centuries. That curiosity has intensified as recent discoveries reveal something strange. The structure of the vast universe bears a striking resemblance to the neural network in the human brain. Is it just a random coincidence or a clue that the reality we live in is not what we thought? Let's start with what we can observe. Looking at images of neural networks in the brain, we see a complex structure with billions of nerve cells. Neurons are connected by countless axons and dendrites, forming a dense, branching network. Each neuron acts as a node, transmitting electrical and chemical signals through these connections. This is where our thoughts, emotions, memories, and consciousness form. Now, let's turn our gaze to the largest scales of the universe observable by telescopes. We don't see individual planets or galaxies, but a massive structure called the cosmic web. This network consists of galaxies clustered into dense nodes connected by long filaments filled with matter and gas. Between these filaments are vast voids where there are few or no galaxies. The astonishing thing is that the structural similarity between these two systems is not just visual. Scientists have conducted quantitative analyses to compare them. A groundbreaking study in the journal Frontiers in Physics in 2020 performed the first quantitative comparison between the human brain's neural network and the cosmic web. The results are astounding. First, the number of nodes is similar. Both systems are organized into networks with approximately 10 to the power of 10 to 10 to the power of 11 nodes. In the human brain, that's the number of neurons. In the cosmic web, that's the number of galaxies with mass equivalent to or greater than the Milky Way. Second, the proportion of passive matter. About 75% of the mass energy in the human brain is water, a seemingly passive but necessary component for structure and function. Similarly, about 68% of the universe is composed of dark energy, a mysterious entity believed to be driving the universe's expansion and playing a passive role in its overall structure. Both have a smaller portion, about 25 to 30%, of active matter, neurons and galaxies performing the main functions. Third, density distribution and connectivity. Power spectrum analysis shows significant similarity in how matter density is distributed in both systems across different scales. Both networks show high connectivity and a tendency for nodes to link into clusters, significantly distinct from random networks. Fourth, the flow of information and energy. Data show that the flow of information and energy in both networks is primarily confined to about 25% of the total mass energy of each system. Fifth, another remarkable coincidence is the estimate of information storage capacity. The human brain is estimated to store about 2 times 10 to the 16 bits of information, equivalent to 2.5 petabytes. Meanwhile, scientists have argued that about 3.5 times 10 to the 16 bits, approximately 4.3 petabytes, are needed to store the structural information of the entire observable universe. These similarities do not mean the brain is a miniature universe or the universe is a giant brain in the literal sense. However, they suggest that there may be the same fundamental self-organizing principles in network dynamics operating at both the extremely large and small scales, despite differences in physical nature and the processes that form them. This structural similarity has revived one of the most fascinating hypotheses in philosophy and speculative science, the simulation hypothesis. The core idea is that our entire reality, including the universe, Earth, and our consciousness, is essentially a complex computer program running on some giant computer. Philosopher Nick Bostrom of Oxford University made the most famous argument for this hypothesis in 2003. If post-human civilizations have the capability and desire to create simulations, and each civilization could run millions, even billions of simulations simultaneously, then the number of simulated worlds would vastly outnumber real ones. Therefore, statistically, the probability that we are in a simulation is very high. Besides the simulation hypothesis, many philosophical schools have proposed ideas that reality may not be what we think. 1. Idealism is a set of philosophical views that hold that fundamental reality is mental, consciousness, or ideas. It contrasts with materialism, which holds that fundamental reality is material. Idealism does not say we are living in a simulation created by an external entity. Instead, it says that reality is mental or based on mind. The universe is not a program, but an idea, an experience, or a manifestation of a larger mind. 2. Panpsychism is the view that mind or a mind-like aspect is a fundamental and ubiquitous property of reality. In other words, consciousness is not limited to the complex human brain, but exists in a primitive form in everything, from fundamental particles to the entire universe. While philosophers ponder the nature of reality, modern physics also presents theories that could change how we perceive the universe. 1. Holographic principle. This is a principle in theoretical physics, particularly in string theory and quantum gravity, which posits that a complete description of a volume of space can be encoded on its lower dimensional boundary. Leonard Susskind provided an accurate interpretation of this principle in string theory and is famous for stating, "The three-dimensional world of everyday experience, the universe filled with galaxies, stars, planets, houses, rocks, and people is a hologram, a reality image encoded on a distant two-dimensional surface." 2. Quantum consciousness. It is a group of hypotheses suggesting that consciousness cannot be fully explained by classical physical laws or neural connections. Instead, quantum mechanical phenomena such as quantum entanglement and superposition play a crucial role in brain function and may explain core aspects of consciousness. These ideas, whether structural similarities, simulation hypotheses, or modern philosophical and physical theories, all have profound implications for our understanding of reality, ourselves, and our place in the universe. If the universe is a mind, or an expression of a greater mind, it would completely alter how we view existence. Instead of living in a cold, material universe with no intrinsic meaning, we would live in a world where consciousness permeates everything. But if we live in a simulation, the implications are different yet equally profound. First, the nature of reality may be deceptive. Our existence, physical laws, our history, all could be products of a computer program. This challenges the most fundamental assumptions about existence. Second, if we are characters in a simulation, do we have any responsibility to our creators? And what moral responsibilities do the creators have toward us, the conscious beings they have created? The similarity between brain structure and the cosmic network is a fascinating discovery. However, it is not evidence for any specific hypothesis about us living in a mind or a simulation. Science is still on a journey to uncover these mysteries. We cannot provide a definitive answer to the question of whether we are living inside someone's mind. Whatever reality may be, the journey to understand it will undoubtedly be humanity's greatest adventure.